Welcome to The Explainer. Today, we're tackling one of the biggest challenges in engineering. How do you predict the future? Or, more specifically, how do you plan massive, complex projects so they don't just spiral completely out of control?
Think about it. How can you possibly quantify the enormous amount of human effort needed to build something like a skyscraper or a huge refinery? Well, it turns out the secret is to break it all down to a single, fundamental unit of work.
So here's our game plan. We're going to start with that core unit of measurement. Then we'll see how you turn a simple quantity into a project duration. We'll dive into why different jobs need different indexes, how to adjust for real-world chaos, factor in people, and finally, take a look at what's next for planning.
All right, first things first. Every single solid plan is built on a standard, repeatable unit of effort.
It's called the man-hour, or hora in Portuguese. This is the absolute bedrock of project planning. It's a simple idea, right? But it lets us put a number on the most valuable, and let's be honest, most variable resource we have, human effort.
Now, to make this man-hour really useful, we have to standardize it. And that's where the productivity index, or IP, comes in. Think of it like a recipe. It tells you exactly how many man-hours you need for one specific task, like, say, installing 1 ton of steel.
Okay, so we have this index. How do we actually use it? Let's walk through the step-by-step logic that turns a pile of raw materials on a drawing into a schedule you can actually count on.
And you know what? The process is surprisingly logical. Step 1, you quantify everything from the blueprints. Step 2, you apply that productivity index to get the total effort. Step 3, you figure out your team size. And finally, Step 4, you calculate the duration. It's a really clear path from blueprint to timeline.
The very first calculation is simple, but it is incredibly powerful. You just multiply the quantity of something, let's say kilograms of steel, by its standard productivity index, and boom, you've got your total effort in man-hours.
This is how we bring those abstract drawings to life with real numbers. And just look at how different these are. That 50,000 kilograms of steel structure, that's going to take over 2,000 man-hours. But the 2,000 meters of cable? Only 500. Big difference.
Okay, so once you have that big number, that total man-hour count, the next steps are all about logistics. You define your crew size, which tells you how long the job will take. Then you plot that effort over time on the project schedule. And that's exactly how we build a resource curve.
But here's the catch. Not all work is created equal. A huge part of smart planning is picking the right index for the right kind of job. The ABIME tables, which are an industry standard out of Brazil, are basically the gold standard for complex industrial projects. And here's something you might not expect. Look at how the lighter structures, like handrails and supports, actually require more man-hours per kilogram. Why? Because of all the incredibly detailed fitting and welding work they involve.
And for piping, you see this absolutely crucial distinction. Work that's done in a controlled workshop is way more productive. It takes fewer man-hours than doing the exact same task out in the field, where you're dealing with weather and all the other chaos of a job site.
So what this all boils down to is picking the right tool for the job. ABMI is for that really tough, complex industrial work. SINAPI, another Brazilian standard, is your go-to for more typical civil and building projects. And trust me, using the wrong one can sink your budget from day one.
Now, a base index assumes perfect conditions, right? But project sites are, well, they're rarely perfect. This is where we have to get real and adjust for the world as it is.
Working at height is a perfect example. Just the time it takes to get up to the work area and manage your materials means that a job 30 meters in the air can demand 35% more man-hours than the same task on the ground. Forgetting to factor that in is a classic recipe for disaster.
So what planners do is they use a formula to layer all these different correction factors. The final adjusted index is your base index multiplied by factors for height, for being in a confined space, for terrible weather, you name it.
All right, so beyond the physical world, we've got to account for the most complicated variable of all, the actual people doing the work.
You've probably heard of the learning curve, and it is a powerful, powerful effect. On long projects where teams are doing the same thing over and over, they just get faster. An 85% curve means that every time you double the amount of work you've done, the average time per unit drops to 85% of what it was before. It's huge.
This quote just nails the modern view of productivity. It's not about yelling at people to work faster. It's about removing the roadblocks. This is why having materials ready and engineering drawings that are crystal clear is so critical.
Okay, let's wrap this up by looking at how this whole process is changing.
So, what's the big takeaway from all this? I think it's a three-part strategy. First, start with the right standard for the job. Second, be smart and adjust it for your project's unique reality. And third, invest in the two things that really move the needle: your team's skills and your ability to collect good data.
You know, we're really moving away from old-school spreadsheets and into these integrated digital models. Just imagine clicking on a single valve in a 3D model and seeing its planned productivity versus the real-time installation progress right there on your screen. That is the future of project controls.
And this leaves us with one final thought to chew on. As all the math gets automated, what's the new core skill for an expert planner? Maybe it's the ability to see the risks you can't quantify and to inspire the human teams who actually turn all these numbers into reality.